PHYS2212, which is on charged tapes. To start, I'll start with the introduction, then the purpose, the important concepts, the observed model, the computational model, results, uncertainties, and finally relevant questions. In this experiment, I explored the concept of electric charges by observing the behavior of everyday materials. In this experiment, it was clear tape. I examined how objects can gain or lose electrons through interaction, such as rubbing or contact, and how these changes in charge affect their interactions with other objects. I conducted a lab to see how static charge can be induced, transferred, or observed using simple materials. This was an introduction to what I'll be learning in this course. I also gained experience in observing and recording physical behavior, which helped me construct the computational model. The charged clear tape ended up having a net positive charge. I found that the charge of the tape is approximately 1.15 times 10 to the negative 8 coulombs, and the tape is deficient of 7.3 times 10 to the power of 10 coulombs. The purpose of this experiment was to determine how much excess charge can exist on an everyday object like a piece of tape. I wanted to know whether the charge was positive or negative and how it affected its interaction with other objects. And to do this, I did this experiment. I also developed a method to approximate the net charge by using force measurements and assumptions about the system. These measurements were then used to calculate the number of electrons missing from or added to the tape, which I labeled as deficient electrons. Important concepts are that the net force is the change in position over the change in time, and that the gravitational force is m times the gravitational constant, which is the acceleration due to gravity in the y direction, and that value of g is 9.8 meters per second squared. This experiment involves several of these concepts. One of the most important is Coulomb's law, which describes the electric force between two charged objects. The strength of the force is directly proportional to the product of the charges and inversely proportional to the square of the distance between these charges. Another central idea was the principle of conservation of charge, which states the charge cannot be created or destroyed, only transferred. It also relied on Newton's second law and the concept of point charges and simplifying assumptions. The observed model was that I created U-tapes by stacking and peeling clear tapes. I saw that these U-tape in my hand was attracted, suggesting the tape was charged, and between the two U-tapes, they repelled each other, indicating like charges. I tested a U-tape against a plastic pen, and this attracted, meaning the pen was negatively charged and the tape was therefore positively charged. I suspended one U-tape on stands and placed the second one directly beneath it. The suspended tape repelled the lower one, and this had a separation distance of 0.025 meters, which became the key measurement for computing electric force and was used in the computational model later on. There was an upward force on the suspended U-tape, which is from holding it. There was a force due to gravity downwards on the suspended U-tape. On the held tape, there was an upward holding force. There was also a downward force on the held tape, which is the electric force from suspended U-tape on the held tape. And since it's in equilibrium, the net force on the U-tape is 0. Some of the physical constants and forces that were used were that the length of the tape that I used was 0.2 meters. The tape surface area was then calculated to be 0.0038. The mass of the tape was calculated to be 0.0002. The tape's distance was 0.025, which, as stated earlier, the atom area is 1 times 10 to the power of negative 20, and a coulomb we know is 8.99 times 10 to the power of 9. These were more calculations that were done, which led to the following printed results, which stated that the magnitude of the gravitational force on the top tape was found to be 0.001962. The magnitude of the electric force is 0, 1.962 times 10 to the negative 3, 0, which is the vector. The charge of the tape is 1.16 times 10 to the negative 8. The charge of the tape is positive because we observed the U-tape was attracted to a negatively charged pen. And the pen is negative due to gaining a negative charge from rubbing on clothing. And this we know just from physics principles. We expect deficient electrons due to the charge of the tape, and the number of deficient electrons, the number of atoms, the ratio of deficient electrons to atoms, and the magnitude of the electric force and gravitational force are all listed here. Some of the uncertainties were that the measure of the distance between the tapes, even small errors in distance, can significantly affect the charge calculation, since this calculation is a much bigger number than we're used to, due to the inverse square nature of Coulomb's law. The assumption that the charge is concentrated at a point or uniformly distributed may not be perfectly accurate. A lot of these measurements were done just by hand and using a ruler, so it's not going to be perfectly accurate. And anything such as air currents, humidity, friction, surface contaminants, or anything could have affected how the tape is or any environmental conditions, and this could affect the calculations. Some relevant questions are: first, what if? If electrons were positive and protons were negative, nothing would change about the physical behavior. Objects would still attract or repel the same way. However, we would describe the U-tape as negatively charged because of positively. This is because the convention of charge sign is arbitrary. The underlying electrostatic interactions remain the same. And finally, the point charge model assumes all charges is concentrated at one point, which is simplification. The line charge model distributes charge along a length, more accurately representing how charge behaves on real objects like tape. As a result, the line charge model usually gives a higher value for charge and is more realistic for this experiment.